got salt. We've already talked about salt, right? Salt is what? Well, what kind of molecule is it? Sodium and chloride, and those are NaCl. What do we call those things that have charges on them? Ions. All right. So one category's got our ionic molecules. All right. Where do the ionic molecules go? Do they go into the oil or into the? Don't answer yet. We're going to go through this and think about it. Do they go into the oil or water? Well, olive oil. When you add olive oil to this mixture of oil and water, does it form a third layer that's separate, or does it dissolve into one of them? Just think about it for a moment. When you take sugar and you add sugar into your salad dressing, does the sugar dissolve into the oil layer, or does it dissolve into the water layer? And then finally, when you add vinegar, I don't know why I put mustard on there. I know, we're going to ignore mustard. Just delete that one. So when you add vinegar, where does the vinegar go? Does it dissolve readily into the oily part, and that's the really tart area, or is it the watery part? So it turns out that salt is an ion, sugar is a polar molecule, like water. Vinegar, it's an acid and actually dissociates and releases a proton into the water and becomes an ion. All right. Olive oil, of course, is like oil, and like all oils, a non-polar molecule. So when you take all of these and you mix them together, what you find is that the olive oil, which is non-polar, dissolves into the oil, which is also non-polar. What's the concept you're trying to illustrate with this whole thing? Other than how to make salad dressing? What is it? Solubility. Like dissolves like. Okay? So we're saying oil, which is nonpolar, will dissolve olive oil, which is also nonpolar. All right? Water, which is polar, will dissolve salt in the way that Amanda described to you guys. All right? Those water molecules encircle the ions and allow them to dissociate and dissolve. Sugar, it's polar, and polar things interact with each other. Water with water, and water with other polar molecules. So sugar will also dissolve into the water. Vinegar, it's ionic, dissolves into the water and releases a proton and makes it more acidic. So, and I'm forget about mustard. Part of mustard is insoluble, so I don't know why I included that one. But I really think it's cool to consider that like a really common household food item exemplifies kind of all of the basic chemistry that we need to discuss in an intro biology class. So when you look over here in hydrophilic category would be ions and polar molecules. They freely associate with water. In the hydrophobic category that won't associate with water, you have anything that is non-polar in nature. Yeah?
Okay, so both ionic and polar react very similarly in a water solution given all that. So what really, I mean, like maybe this, I don't know if this is a well-worded question, but what really separates those two then if they behave similarly?
So one way to think about it is it's kind of the scale of charge. So ions we typically think of as having sort of like integer type charges. So it'll be +1, +2, -1, or -2. Polar molecules just have a slight positive side or a slight negative side. So ions, remember, are a complete lack of one or more electrons, or one or more electrons in excess of the protons.
Okay.
So does that?
So in this particular circumstance, the polar, even though the polar has got a sort of a cocktail of some other things, it's still water is enough to dissolve
Yes.
this one, whereas, okay.
I don't know, does that address your question?
I believe so.
Okay. So that's our like dissolves like concept. Ready to move on to the next one, which is small pebbles can make big biological waves.